looking at applications of causal models in the learning analytics space. A little bit about me first, because I came to the learning analytics path via spending a long time in the classroom, my last timetable as a maths teacher, and then through a brief detour into farming. That's a longer story I won't go into. I ended up analysing learning data from a much more removed and distant viewpoint at an institutional scale at Charles Sturt University. So I have experienced, pardon me, both sort of at the immediate level of the student interaction in the classroom, understanding the learning context, and also at a removed analytical point as well. And one thing that is consistent is that at neither ends of that spectrum is the story simple. But for a moment, let's imagine it were. For example, if we were looking at astrophysics and we have a giant object such as the planet, and we want to abstract that into something useful we can play with, and we can shrink it down into infinitesimal point, and then do lovely things like run simulations, build theoretical models, test those theories, and make predictions. But it started with this nice way of abstracting from the real world into a construct which people in this sphere don't necessarily argue about. However, learning is not like that. Learning is complex. There's no sort of agreed way that we would take a student and their important attributes, reduce them to a set of points, and expect that everyone's going to agree that this was the right thing to do and the right way to go about it. Now, this, what happens with this is it makes modelling hard because it's difficult to get that very, very first step. It also makes understanding causality hard, and because understanding causality is hard, then it makes it difficult to make better interventions because we don't know what levers to pull. So that's where my work sort of starts in the sphere of like, how do we make better interventions in the educational system to get better outcomes? I'm going to, for this talk, I'm going to sort of go down the left-hand branch of the thesis structure first, where I'm looking at sort of the benefits of this causal modelling product, and then I'll go down the right-hand side where I'm looking more at like, well, what are the benefits of just doing this process of building causal models? There's a little bit that I am skipping over today, which is sort of joining the two, but it's delving into applications to theory. But one thing that we can agree on, largely in education, is that it's about improvement. And to do this, we need to instigate change. We do that by making interventions. Now, learning analytics is often talked about actionable insights. So the idea that being ideally what we learn from the data, we can then turn into some kind of action to improve learning outcomes. And in fact, others have gone even further, saying that these insights that we do gain from data, it's critical. We have a moral obligation to act on. Now, the trick, however, is that these interventions require a causal claim. So to make an intervention, we need someone to do it, an agent. We also need them to do something, so take an action, and we would expect then that the action has some kind of change in our system. Now, that little connection there between the action and the change is a causal claim, which is saying that if we do X, then we expect a change in Y. Now, before I dive into that too much, I just want to acknowledge that the realm of causality is highly contested, has been for many, many years, and it's difficult to formalize. I'm going to look at Pearl's way of viewing causality, mainly because it frames a nice way to view how we make causal insights from data. And that's very pertinent to making actionable insights from learning analytics. So Pearl and Mackenzie have a nice construct called the ladder of causation, which is basically sort of looking at different levels of evidence that we might gain, sorry, not levels of evidence, levels of claims that we might make from data that require different levels of evidence. So starting down at the bottom, I know that's small, we have where we are just seeing patterns in the data. And this is a level of association. So for instance, we might notice that lots of visits to the university library are associated with better academic performance. As we move up the ladder, we move to the intervention level, which is the doing level. And this requires a little bit more evidence. If we use the library example, this would amount to, well, imagine if we could force some of these students to go to the library more often, we would then see an associated change in their academic grades improving. This all of a sudden doesn't make as much sense because this is looking at a causal claim. We are saying that if we're not looking at just these two things being associated, we're saying that if we change one, then we expect a change in the other. And this requires a different kind of reasoning. The top level is of Pearl's ladder is the counterfactual level. And this is more about sort of looking back on when interventions have happened. So for instance, what if the library had been shut last year? What would have the impact have been? So this is about asking like, what if questions, imagining different scenarios. So I guess the take home is that these causal claims are about more than just statistical association. They're more than just seeing patterns in the data. So I want to turn now to, well, how is learning analytics making claims about causality? And by and large, they are not. There are two reviews that I found that sort of look broad scale at different components of learning analytics and how the evidence was being assessed. The first was looking at sort of at-risk students, and it's just a really small smattering, only 11 out of nearly 700 that sort of attempted to use analytics to understand the effectiveness of their interventions. An example with dashboards fared a little bit better, but still by and large, these causal claims are not being made. Where they are made, learning analytics tends to use experiments. The most popular is the so-called gold standard of randomised controlled trials. And these do run into some issues, which I'll talk about a little bit later, but they are a really good way of making a causal claim from data, but you need to design them. You need to set up an experiment where ahead of time, I am going to test the effect of X on Y. I'm going to split this group into two. Some people are going to get an intervention, some are not, and then we're going to compare the differences at the end. These can sometimes be snuck in as well to existing systems with embedded experiments, and they can also occur naturally where maybe we accidentally only send the email to half of our students that was meant to be part of an intervention. We might have a naturally occurring randomised controlled trial. Now, these are good. However, they are quite rare in learning analytics because of practical concerns. They can be expensive and ethical concerns. So for instance, if we've got an intervention we think is really useful, it can be seem to be a little bit unfair to give to some people and not to other. Oh, the bell is just finished. In terms of also by their actual setup, randomised controlled trial is almost by definition slightly out of context and unrealistic. You're trying to level everything else out and only vary one thing. So in a complex system such as learning, where you have lots of effects interacting with each other, they can be very impractical to actually run. It still doesn't mean that we don't use this kind of, we don't make interventions without them. For instance, there are no randomised controlled trials for surgery, for drink driving, or for lecture attendance. Right. The other way is if, okay, we can't set up a randomised controlled trial, we can't set up an experiment, we do collect a lot of data. Then what can we do after the fact to adjust for all the other effects that are going on to isolate the causal effect that we're interested in? And this is where a whole suite of methods come in that mostly center around adjusting the associations that we are measuring in our model to try and filter out and tease out the causal effect of interest. Now, the main one that people would use is just standard regression model. We add in some extra variables called covariates, and they do the filtering for us. The key thing there is that we have to choose which ones. So that choice relies on knowledge of what the system is. It relies on the causal knowledge of which variables to include and how they interact with our intervention and how they interact with the outcome. There's a similar one that is used in the next most popular one in learning analytics was propensity score methods. These work in a similar way, but this time we've got this step in between where we're building a model to predict the propensity or the probability of a student, for instance, receiving the intervention, and then we normalize the effect according to that score. There's a bunch of others, but the thing with all of them that I want to take home from this is that they all do rely on some knowledge of the causal structure underlying the system. Which is not surprising then that there are ways to draw explicitly this causal structure in the form of a DAG. But what are DAGs? So you'll be seeing lots more of these in a moment, but the G stands for graphs, which just means nodes or points connected by edges, which are just lines. Did I say G then? That's definitely a G that it stands for. The D stands for directed, which means the lines are arrows. They have a direction, and the A is for acyclic, which just means that if we follow the arrows around, we don't form in any loops in any path. A causal DAG just means that that graphical structure represents the flow of causation between variables. So if we're going to sketch a little simple example, we might see that the wind blowing and the trees moving are associated. They seem to happen at the same time when it's really strong, the trees moving lots, and the wind's blowing strong. Now, if we wanted to form this into a DAG, we would have to draw an arrow between these two. We don't base that on the data. We base that on our experiential knowledge or our scientific knowledge, and we draw the arrow from the wind blowing to the trees moving. This has really important consequences for interventions, because if we were going to intervene in this system, you can imagine if we wanted the trees to move less, we could put up some great big walls around them and stop the wind blowing there, and we would expect to see the trees to stop moving. However, we couldn't intervene the other way. If we wanted more wind, we wouldn't go out and get great big machines and shake the trees. We just know that it wouldn't work that way, and that's the knowledge that's represented in that graph. They've been used to model a range of systems over the past 100 years, starting with the genetic characteristics of guinea pigs. They're quite big in econometrics, health sciences, and epidemiology. And there is the one example that I found in learning analytics, and I'm still looking. However, strangely, even though I didn't find many in the learning analytics literature explicitly or in education explicitly, there are a lot of papers outlining, like sort of tutorial style papers that use examples from education. So here's one that's using an educational example from some statisticians arguing for graded distances. Here's another educational example, but from a personality psychologist. And then there's another one, this is the Berkeley admissions paradox, which is an educational example from an evolutionary anthropologist. Now, that sort of leads me to that my first gap is that there are few of these claims being made. My question to follow, to interrogate that, is that, well, how can we better make rigorous causal claims? And I want to follow the approach of using these graphical causal models to do that. Now, my justification for that is that I think that the product they give at the end is nice and robust. One, because useful because we don't need to rely on an experiment, we don't need to rely on RCT. I think that's very, very key. They have a place in education, but where they're not possible, this is a way forward. It's important to note that this is not the only way forward with this. However, the graphical causal models explicitly draw the causal structure. This makes the assumptions scrutable and allows for easy interrogation of the assumptions. And I believe in the long run, that will make for a more rigorous method. And finally, a key thing that I think is important is that you can see on the DAG where the intervention is happening. And I think that helps your understanding of not just, it helps your understanding of where the impacts of your intervention are going to affect in the flow on causation, not just being able to measure a causal effect at the end. So initial work with looking at this, so I've started looking at, can this be done? So how hard is this going to be? So my initial test case was in a context that I know about, which is my work with Charles Sturt, and we're looking at our intervention model that we use for student retention. And this was published in LAC this year. And the construction of the model actually came about through a series of sessions with a fellow KIT researcher. And they were very, very unstructured because it was just exploratory. But what came out is I ended up sort of playing this natural role of the person that knew about the context. And my colleague at KIT, Leonie, she sort of played this role of the data expert. She would see the graph I draw and then interrogate it more to try and get what I knew about the system onto the page. So we ended up sort of for the paper and afterwards I sort of reconstructed this dialogue between a data expert and a context expert, sort of building this model together. So here is Ed. Ed is our educational data expert, knows about the context of the education, but not enough about data science to build these models. We also have Dat, and she is an expert in the data side of things, but does not necessarily know about particular context and the meaning that results might have. So the model we're interested in is like, if we see a student that is, we think is at high risk of failing by non-submission, so not submitting any assignments at all, we give them a phone call. Some answer and some do not. And hopefully that's leading to a better chance of success. So Ed has some data and wants to know, do the people that answer the phone call, do they have a better chance of success? Now, that goes, well, I can crunch some numbers and voila, it looks like that the people that answer the phone call and have a conversation, they are 3 times less likely to have this dramatic failure situation. So the follow-up question is, so there we've seen an association data. And the follow-up question from Ed is like, well, the conversations helped them. But this is a different question. The first was about association, and this is about causation. And it requires more evidence than just the pattern we're seeing in the data. which is a problem because, well, this is the kind of question that we want to answer if we want actionable learning analytics. We want to actually change the systems we're investigating. Fortunately, Ed has some more information here and has some ideas, and worry that, well, maybe these students that have a better academic chance of success, they're also more likely to answer the phone. And this is a classic, so Dad would see this and go, this is a classic example of having a common cause, and I know this is confounding the effect. So here is where we sort of dive into the dialogue between these two, where we explore, okay, can we sort of think about other variables that might help, or what is actually going on with his original process? Are we actually changing their chance of grades directly, or are we actually, when we talk to them, is there some other construct that we're not measuring that's actually the mechanism between them? And so this is where we sort of brought in this intermediate variable here, because we're not changing the grades. We're going to call and talk to them and the grades get better. We hopefully influence their decision-making capability, or something around like their academic capabilities about what they're doing. And that in turn is helping them have a better educational outcome. Here, however, there's a little bit of a feedback loop because we're worried that the decision capability is also affecting the chance of talking to the student. And this is where the formal constraints of the DAG start to influence what these two people are doing in this conversation. So the constraints of the DAG are we have that they're acyclic. And the reason for this is that it's going to make it easier to interpret for the statistical machinery that we need to make an estimate of the causal effect. So what happens now is we need to do things like split the decision-making capability into two epochs, so the before and after, and that sort of disentangles the loop. And so what's happening here is that we're sort of incrementally formalizing our structure to make it more interpretable for the machine. We then look at some any other indicators that we might be able to measure, because at the moment we've got this decision-making capability which is kind of amorphous and latent, and we can't measure it. So the rest of the conversation is develop this student indicators one, which we haven't really modeled yet, but it's representing the factors that influence the decision-making capability before the phone call, and possibly the chance of talking to a student. And in the end, at the sort of last point of this model, we're like, well, okay, we're actually not entirely sure about one of those parts. So just drawing that in as a dotted line. Now, in the end, we get this structure, which is nice and transparent and can be used, given the data, to make a causal estimate, depending if we can measure everything there and depending on its shape and structure. Now, the next step with this bit of work in terms of making a causal claim will be getting some ethics to apply this to a real data set, because at this stage, this is all just a hypothetical decision, although it's been based on my experience with Charles Sturt. We could also apply this to other data sets as well, though, because as long as the intervention follows something similar to this pattern, we can hopefully apply it to different contexts. Part of what will need to be done is just expanding on that student indicators little blob there. That's not like a variable sitting in the data set, but it is important to be able to estimate the causal effects here. So we'll need to find some proxy variables of that and then sort of include them in this structure as well. And from there, we can test this on data and make a causal claim. Because of the dotted arrow, though, because that's representing uncertainty in the causal structure, we'll need to do a sensitivity analysis of those claims to whether that path is present or not, or maybe degrees of strength of that path. And that's first contribution to that research question one. In particular, we're making a rigorous causal claim, which is not the first in learning analytics, but using the graphical causal models to do so is very, very rare. Then I'd like to look down this other branch, and this is sort of examining more the process of constructing these causal models. So for the interventions to happen, someone needs to act, and it may not necessarily be the person that did the analysis. Now, in my experience as a teacher, I would be walking around the classroom, making observations, I would have assessment data, I would know where the students are at, I would be forming a model in my mind, I would be analysing that and then deciding on what kind of interventions to make in the classroom. There's no distance between the person doing the analysis and the person doing the action, making the intervention. This can't be said for what happens at scale with the datification of education. So we have to have some kind of shared understanding between different stakeholders that are facilitating different roles in the learning system. As such, the people that understand the context and take the actions are often removed from each other, and as such, learning analytics has to operate in this middle space between these areas of expertise. And due to the complexity of the system we're looking at, the different viewpoints may be just equally valid and consistent. And that's not necessarily a problem, that's just the way of things. And that actually might be seen as a strength, that to understand the system, we do really need these multiple viewpoints. But how we do it is a challenge. So returning back to this sort of construct between ed and dat. Now, this is sort of like a crude distinction. I've only got one there. And realistically, people do have a little bit of a foot in both camps. However, this is more of a representation of the dialogue that needs to happen either within the person's mind or between a range of experts and between the two sides of the people that need to, or the task that's assigned with doing the statistical modelling and the importance of understanding the context. So on the education side, one of the challenges for those on the ground understanding the educational context is they do not have the technical or statistical expertise to interpret the data. I mean, if they did, they may be doing it themselves. That's why we have to work together. On the other side, though, the data expert may not necessarily understand the full context of the learning system that they're trying to analyse. And they may do things like optimise it, things like speed and accuracy, possibly at the expense of making it meaningful for the system that we're trying to intervene in. So this sort of creates a gap between these two ways of thinking. And this is sort of evidenced by some of the ways that learning analytics has tried to address it. One of those is co-design, where which is a suite of different kind of tools and processes that help the people building the learning analytics products elicit the knowledge from the context experts, include the end users and that kind of thing, so that the systems that they build are better informed and more suitable to the end user. One of the challenges with this is that it is a very laborious process and it's not necessarily generalizable to different situations. You really do need to go into each case and extract the knowledge relevant to that context. Taking a more, learning analytics is also strive to try and find a more generalizable approach. And you can see this in the calls for stronger theory in learning analytics. So the idea is if we have stronger theoretical constructs, then maybe we can have these better informed learning analytics systems that are informed by, say, the learning sciences. There's been quite a bit of work in dashboards informing them on things like self-regulated learning theories, so that you sort of like have underlying principles that do a bit of this legwork first of understanding the relevant context for your particular learning analytics tools and products. This is still, people are still calling for this. It's still very much under active development. It's clearly a very, very hard problem. So we have the data context gap. I'm hoping to address this by trying to understand how we can inclusively build learning analytics to embed that contextual knowledge with a wide range of stakeholders. And unsurprisingly, I am hoping to do this with graphical causal models as well. And in particular, that this is kind of stemming from that hypothetical dialogue that I had before, because although the product was quite nice at the end, like the lure of getting a nice causal estimate from the causal model, what became apparent in those early sessions was the process of building it, and in particular building it with someone else and talking with them about it, was very illustrative. So it really, I thought it really helped think about the system, because the act of constructing this model provided some kind of scaffold for how you were going to abstract from the real world to the system. Remember that example with the planet and the point? It's really difficult in learning analytics. We need kind of tools to help with that. And also, not only that, I think it's going to enable a wider range of people to take part in this highly abstract process of building causal or statistical models, because the graphical representation is so simple, is dots and lines. So the next step was to take that hypothetical sort of artificial construct of the conversation and actually do one with myself as a data expert and some other experts in the context that we're interested in studying. And so there was some work happening at Kick on belonging, so the student's sense of belonging. And I thought this was a good chance to prototype this participatory causal modeling methodology. So it was done with 2 people over a few sessions, independently of each other. The first researcher was an early stage researcher reading the literature, and we thought, okay, let's try this out as a dialogue. Let's try and build a causal model of belonging based on what your current understanding of literature is, and see how helpful it might be. The second one was a latter stage researcher who was more interested in the case of what's the influence of the teaching and learning environment on a student's sense of belonging, and how does that then flow on to things like engagement and better academic outcomes. So the first belonging sessions began with trying to place like the most common variables that we were seeing, or constructs we were seeing in the causal modeling literature. Sorry, not that we were seeing, that the researcher was seeing. And then slowly building, okay, which other ones do we need? Can we justify the links between them? What happened over the course of this is that the graph sort of kind of expanded and contracted. Some of the variables sort of changed names. You had to really think carefully about, okay, how do you actually want to split up the way people are talking about belonging? It's more like a classification exercise, but with this added layer of what flows onto what. And we ended up with this was the final causal model. So we're splitting belonging into 2 types, the interpersonal and the academic belonging. And of key interest was that influence on engagement and achievement, but also the kind of the different aspects of the student's background and how they influenced how belonging worked in the system. The second researcher, actually notice we're using a different tool here. I just want to flag it. This is Daggity. It's really good, but you'll see the bully stuff on the outside. because it's really designed from the point of view of someone trying to understand the effect of a treatment on an outcome. That's based from the epidemiology field. So it's always about understanding the causal effect. It's not about sort of just wanting to try and conceptualize a certain field. So you'll see the nodes as we go through sort of change colors. As we go along, we'll see some of them blue, and then we get red ones later. All that's for, it's the machinery, the mathematical apparatus that lies beneath the graph that helps inform the statistical model. So we can draw the graph here, and we just do the hard work drawing the picture, and then the mathematics behind it helps inform the statistical model. These are the covariates you need to include to adjust to get the causal effect. Okay, so for now, just ignore the coloured dots. The end result. There was a good moment here in the discussion that I want to highlight. It sort of exemplifies the kind of thing that happens. So here we got to a point in the graph, like we've drawn the lines we think are there, and then myself as the modeler, the data expert, said, okay, are there any other variables that are important? And the researcher says, motivation, and actually self-efficacy is an aspect of motivation. So this is a really, really key point, because there's the causal system, there's the researcher's understanding of that causal system, which I'm trying to pull out in the discussion. The researcher is then sort of verbalizing that, and sort of that's most of the work is done there. It's just gone from this abstract idea of how these things are interacting, describe what's happening between these variables. However, because of the formal constraints of the DAG, I need to draw an arrow between these two things now. I don't know which way it goes. That's helped me probe further questions, go, okay, exactly how does that fit in to this existing picture? So again, we've got this incremental formalization of our thinking around the system that is being pushed forward by the constraints of the causal model. And also, I think, like, supported by the fact that we are pushing some of our cognition out on this diagram. Slowly build this, it gets messy. Actually, one of the researchers' aims was like, I think this system is messy. I want it to be represented there. And we certainly achieved that. However, you can tidy up. Okay. One of the challenges is, as you draw lines, it gets, but you can make it a bit neater if you just rearrange them. What was useful here is we end up with this this model. There's no data or anything. This is our conceptual model of what causes what. However, we do have a little mechanism at the top here around the teaching and learning environment and some of the influences in there. So one of the handy things we could do is if we could get some estimates of the strength of all of these paths in here, we can run a simulation. And this is going to be one of the next steps. Because once we can do that, we can run simulations with this whole structure and test and evaluate how well does this fit what the phenomenon we observe. And then we can play around with things like, okay, see the mode of delivery. What if we switch that for everyone to be suddenly online? What happens then to our system in terms of student sense of belonging, and how does that impact the rest of the system? So in terms of the next steps for this participatory modelling methodology, I need to get ethics to do future sessions where they're going to be more formally recorded and transcribed. Need to refine the methodology a bit, and qualitative analysis of these sessions as well, to try and extract sort of not only like build a contribution in terms of the methodology itself, but also sort of analyze, well, what are the useful parts of it, and what are really the limits of what this can do as well. So this belonging model has also got contributions to the first research question. I just talked about sort of listing the parameters as the next step, and then simulating to test that structure as how well it represents the phenomena of interest. I will skip through these because that's the plan for the next few years. Broadly split into the causal model product at the top there. So building the skills to implement those and make causal claims. And then the building of the participatory modelling framework, where I will need to skill up on some qualitative analysis, get our things, run the sessions, and sort of analyse what value can be extracted from those. I think there's some potential papers, particularly with the simulation and theory and for learning analytics. I think that is an avenue that's been explored in other fields, but not in LA, and also on the participatory modelling front. Thank you.